Welcome back. I hope in the last class we were introduced about the different types of modeling, right? And we seen that what the name of the three different types of modeling. One is a gate level or structure level modeling approach in Verilog. Second one is data flow modeling approach, and third one is nothing but behavioral modeling, right? In today's session, let me see about the data flow modeling and how this data flow modeling is differs from your structure level modeling or gate level modeling approach. Okay, right, let me proceed forward. So to understand this, once again we can take the same example of your previous one as 2:1 mux, because that is more easy for us to do the programming in a simplest way over here. So what is that a previous example we seen? That is nothing but 2:1 mux, correct? Let I complete the diagram quickly without any wasting delay, because we already seen that 2:1 mux. I am going to give the name of it. Okay, instead of not 2:1 mux, because there won't be any confusion, let me give a module name. Okay, I am going to give mux 2, because otherwise you will get confusion. So I am giving A, B as an input, select line as an input. I am going to get Y as output. What is a Y? Whenever there is a select line bar should be there, I want to get A as output, and whenever select line should be there, I want to get B as a output. I am going to give a dot product here because it is a AND operations. Then followed by we have a output line, select line we have, okay, and we have a and we have a B and we have Y. All of us know about this. Okay, so according to the table we know that whenever select bar, A should be available irrespective of the input B. Whenever select line is 1, irrespective of input A, I want to get output as a B. So I can write 0 1 0 1 without any confusion. We can write directly. So now we know the expression, right? In data flow modeling, it's very important. We know the expression. What is the expression? Y is equal to select bar dot A plus, okay, and what is it? Select line dot B. This is the expression. We know about it very clearly. That means the data flow modeling, we do the digital system design. One who doesn't know about its internal logic diagram. I am not going to draw the internal logic circuit diagram here, because that in the previous case we drawn, you do remember, in the gate level modeling and structural modeling. But in this case we are not going to draw the structure of your mux, internal structure of the mux. We are not going to care about it. But if the designer he know about the logic expression, or if he know about the functional relation between the input and the output, so that we can directly go for a programming. That means if we know the Boolean function of any kind of a system designs, the programmer can easily start to write the program. So there is no need to worry about what is the internal structure of your particular block. So this type of approach we can use to call it as a medium abstraction level. Medium abstraction level, where it's going to be handle the circuits in a more effective way just by seeing the Boolean expression or the functional relation between the input and output. We can directly write the program in the sense. So how we can able to write the program, that we will see it over here. How we will start? We will start with the module name. Am I correct? So what is the module? Is nothing but mux 2, correct? Input is A, B, output is Y, input is select line, and we write this also. Y is equal to select line bar into A plus select line into B. So how we will start? We will start with the module, right? We start with the module, followed by what? Module name. What is the module name? Mux 2. We can write mux 2, and followed by what we should write? We should write the all variables which is connected with the system irrespective of the input and output. So we can write A comma B comma select line comma Y. So once we start with the module, what we should end? We should end with the end module. We write end module. Okay, we will write the end module. Do remember there should not be any colon and there should not be any space. Okay, that I did it and I will write once again so that it will be more clear for you. You can write end module. End module. Okay, so module name is defined, and followed by we should define which is input and which is output. We can write input. What is the input? A, B and select bar. We can write A comma B comma select line is going to be the input, semicolon, and followed by what should write? We should write the output. So we can write output A, so not A comma, because there is only one output is available, that is nothing but, there is no even bracket is not required, there is nothing but Y we can say, output we can write. Okay, so that is what way in which we are going to write now. Y is, so now instead of going with the structural, we just go with the Boolean expression. What is the Boolean expression? We have Y is equal to select bar A plus select A. We can directly write that expression like that. How we can write? Assign. We are going to use the keyword called what? Assign. It's very important. Assign. What we are going to assign? I am going to assign some values for Y. I am going to assign some function for Y. What is a function for Y? I am going to assign Y is equal to S bar A. What we can write? We can say negation symbol of select. This negation is indicating what? Bar or inversion. S bar A in the sense dot, I can write use dot. This dot is indicating what? AND operation. Directly the dot is indicating what? AND operation, or it's one bit multiplication it is going to get indicated, and this can be put in a bracket, okay, because it should not separately. Then what is available? Plus, that is nothing but OR operation. So the OR operation can be denoted by this symbol, OR operation. Followed by what is OR operation? Select dot B. So we can write, how we can write? Select dot B. Do remember? Semicolon. It's very simple. When you compare with your data, your gate level or structure level modeling, if the designer, he knows the Boolean expression, he can directly write the program over here. He no need to worry about what is the logic diagram, how many number of logic gates it is available, how many number of physical links are available between one logic gate and another gate, whether we give a name properly or not, it is not at all required. I don't want even truth table also. If the developer, if the person is going to give it to you, this is my Boolean expression, in the sense we can directly go for designing. That is the advantage to go for the data flow modeling, and that is the reasons why we used to call this as a medium abstraction level when we compare with your structural or gate level modeling approach. It's very simple, right? We directly wrote the assign. Assign is an important keyword while going for this kind of data flow modeling. Assign Y, directly we are assigning some functionality. What functionality it is? We will indicate the functionality through the symbol. So here this is indicating what? NOT gate, and this is indicating what? AND gate operation, NOT gate operation. Okay, this is on AND gate operation. And what this symbol is indicate? This symbol is indicate what? OR gate operation. Okay, so this idea about what is the different symbols, that we can able to verify the different types of symbol indications on the Verilog programming. That is more easy for us to be understand. Okay, so that is what the way in which your data flow modeling can be written, while we are going to talk about this in the modeling approach by using your data flow over there. Okay, even sometimes we can able to introduce some conditional statement also possible. Conditional statement, we can replace this with a conditional statement. That means this is also correct, but we can replace this as a conditional statement. Let's say for example like this: assign Y is equal to S, Y is equal to S, double equal to 0, then we can keep a question mark A, then colon B. Okay, what is that? Instead of this expression we are writing the same like this. We are assigning value for Y is equal to S double equal to 0. That means when, then what is S? here select, okay, I'm sorry, select line. When select line is double equal to 0, if it is true, this question is mark is indicate what? If it is true, then you output as A, or else you just output as B. Are you getting my point? It says that y is equal to, select line is double equal to 0. What is select line is double equal to 0? A must be come as output according to the truth table. So, but here you do remember, here also we should know the functionality, because from the expression y is equal to select line bar dot A plus select line dot B, what we can understand, when select line bar is equal to 0, select line bar is there, A should be output. Same way we are indicating here in conditional statement, select line is double equal to 0 means what is the meaning? It's a select line bar, means what should be the output? A. If it is true, this question mark symbol is indicating true condition. If it is true, assign the value of A to Y. If it is false, assign the B value to the Y. What is the ulta way we can write? We can write another way. How we can write? Assign y is equal to, how we can write it now? First we just wrote for select line bar. Now we write for the select line. How we can write for a B output? We can say yes. We can say yes. Yes means what is the meaning? Sorry, select line means what is the meaning? Select line. It is not select line bar. It can be equal to 1. Select line, we can say question mark. What should be? If this is true, we can have B as output, or else we can have a as a output over there. Right? So, this statement we can replace with your conditional statement also. This is also correct, and these two statements also correct. Whichever the way in which we can write the program, we can able to develop the program through your data flow modeling. So, what we can able to conclude when we talk about this data flow modeling, if you want to develop the data flow modeling, we should know about the Boolean expression of any logic system which you are going to implement. Okay, so that is the reasons why we used to call this is going to be a medium level abstractions when we compare with your structural flow. So I believe you got the differentiations between the structural level modeling and as well as the data flow modeling by using the same example which we discussed in the last sessions, right? So this is when we compare with your previous one, this is more easy and it is more going to be time consuming, and the designs can be made it very easily by means of writing the expression directly by means of writing the keyword called assign. Don't forget that assign keyword, it's going to be more important when we talk about this data flow modeling over there. Okay, so in the next session we come with some another type of modeling that will be called behavioral modeling. It's going to be more interesting and it is going to be more easy to write when we compare with these two types of modeling approach, right? Thank you so much.